Yeah, so hello everyone. I can hear. Hello. Hello, can you hear me?
Yes, sir.
Yeah, okay. So we will start today's session. So as usual, I am so we will be taking the problem solving session for natural language processing, which is a course conducted by NPTEL, and instructor is Professor Pawan Goyal from Indian Institute of Technology Kharagpur, and I am Punyajoy Saha, who will be the teaching assistant for this course. Now, going to the first question, so this first question is actually the fourth question of the assignment. So, in Saturday's problem solving session, you have already covered, I think, the top four. So, I will be continuing from that. So, so that we can cover all the questions that are there in the assignment. So, till now, we have covered more or less how to find the maximum likelihood, how to apply smoothing functions, and everything. Now we will move to hidden Markov models. So first, can someone explain what is hidden Markov model? You can just write in the chat maybe. Okay, yeah. So till now we have completed like I think smoothing functions and like how to find the MLE for language models, and then perplexity and all these things. So now we are moving to the hidden like the Markov models, and then we will see how to apply them essentially, and we will see different decoding algorithms in this problem solving session. So here we are presented with a question which is about hidden Markov model. So since the entire discussion will be around, so let us first discuss a bit about what is hidden Markov model. So can anyone write in brief what is hidden Markov model? Yeah, anyone? Can anyone say? I will again share my screen. Just let me know if you can see it. Yeah. Yeah. So I was asking about what is a hidden Markov model. Can anyone say? Yes. Anything else? That is okay. Markov model. Okay. Anything else? Anything specific? Okay. So you are more or less correct. So they are like statistical machines which are using that theorem that previous the current state or the depend on the previous state. So anyway, so we are provided with two things. One is the hidden state transition matrix. So this is how the transition is happening. So this is essentially a pause tagging framework. So a pause tagging. So what is pause tagging? Pause is generally parts of speech. So if you have a sentence, you want to assign different words with different parts of speech. So something can be a noun or a verb or something like that. So now here this T1, T2, T3, T4 are different pause tags, and the words are key, fin, and yeni. So these are the different words, and we want to we want to calculate this part. So calculate P y3 equal to t3 given y1 is equal to t4, y2 is equal to t1, and x1 is equal to ki and x2 is equal to fi. So y1 and y2 are the two pause tags of the previous words, and x1 and x2 are the words. So if we try to represent it, yeah, if we try to represent it, we will be saying, okay, uh, this is the word uh, ki, comma fin, and this word has a pause tag of t4, and this word is a top pause tag of t1. And now you have to find the third word, that is x3. So we do not know what is x3, and we have to find that what is the probability of that this is t3. Did you get my point? Yeah. Did you get my point? Yeah. So now that is the task. So now let us see the options. These are the options, and then we have this formula. So this is in lecture 3rd, and like a presentation of the tutorial, like the lecture materials 3rd week, and here we have to. So this is essentially the formula that you have to. So P Wi given W1 Wi minus 1 comma T and T2 T minus Ti. So this W1 is again watts and T1 to Ti are again Postak. So it is saying that the word probability of the word appearing depends only on its own Postak. So that means that P of Wi given Ti. So the Postaks of the word of, so the probability of the word only depends on its own Postak. And secondly, the bigram assumption that the probability of a tag appearing depends only on previous tag. So P Ti Ti minus 1 Ti given Ti minus. Here again, these are like simplification techniques because we know that it is already a Markov chain. So now what will happen here? So we need to find the probability of this value, right? So P. Now what do we know by the second rule? That Py3, which is the Postak T3, will only depend on the past Postak. So what is the previous Postak? So Py3 equal to T3 will only depend on which one? So Py3 equal to T3 will depend on we just now learned the form, like the theorem or the simplification of the theorem. So what will be the simplified formula for this? Yes. No. Y1 is the first one, right? So we have Y1, Y2, Y3. So Y3 will depend on Y2. Yeah. So that is correct answer. So it essentially becomes, the entire thing essentially becomes Y2 equal to T4. Y2 to T1. So this we have to find out. Now how to find this? So we can look at the table. So we have to check Y2 to T3. Sorry, T1 to T3. T1 to T3. So this one, 0.8. Yeah, is equal to 0.8. So that is the correct answer. So one similar question was also there. So yeah, so 0.8 is the right answer. Do you have any questions? Okay, so there was another similar question that was in this assignment. That is, this was another question, the same assignment. So can you tell me how to do this? We do not need to do the calculation as such, but can you tell me how to do this? So again, the concept is similar, but we have to apply the previous rules that we learned. here they are not asking the conditional probability, but we have to find the total probability. So what is the probability of, so what are they asking, that what is the probability that this sequence will occur? So x1 given t2, sorry, x1, that is ki given t2, ki and the pos tag is t2, pin and the pos tag is t3, and y2 given, sorry, ENE given the pos tag is t3. Yeah. So what is the probability of this sequence? So they are asking this.
So y1 is given as t4, right? So,
No, no, I am asking. This is a separate question. So this one is a separate question, not related to this. So this is another question. We have to find out the probability of this equation, this probability. So this we already solved. Like, so we got 0.8 using the using this formula, that the probability of a tag appearing depends only on the previous tag. Now we have to calculate the probability, or now you have to calculate the whole probability, the probability of this whole sentence. So how do you do that?
first we start with y1.
Okay.
Probability of y1 is equally likely amongst all square given
Yeah.
probability of y1 equals to
T2.
t2 is 1 by 3.
Ability of y1 equals, okay. Y1 is equal to T2 is 1 by.
Because the first tag is equally likely.
Yeah, but there are, if you see, there are 4 tags. So you are correct in a way, but yeah, but 1 by 4.
Tags.
Yeah,
1 by 4.
correct. Then
Then
so let us write it.
probability of
Okay. So you are saying probability. So we'll first look. So will there be only y1 equal to yt2 or something else as well? So try to see this formula.
yeah, we start with y1 equal to t2.
And then
Then
because it do not have any ti minus 1, that is correct. But what after that?
after that it is x1 is equal to t.
X1 is equal to t given.
X1 t given y1 equals to t2.
Yeah, correct. Yeah, so you have got the point. So now similarly you can extend it to like others also. So what is the next term?
y2 equals to t3 given y1 equals to t2.
Y2 is equal to t3 given. Yeah, here the term comes because you have the previous term. T2. And then you again add the next
x2
thing.
equal to 10.
Yeah.
And y2 equals to
Yeah. Y2 equal to. Yes, that is basically the solution. That is others understand how we did this, and then you can basically just put the value based on this transition table and output symbol properties. So that is not much of an issue. So only thing to focus on, only thing to like take care here is that you do not miss the values, because that will give the wrong answers. So once you have this, so the better solution is to write this entire formula and then replace each value. Because the values are very similar, it is easier to like do careless mistakes. Anyway, so this is the basic formula. So, and this will be based on this that we have. So Pwi by Ti to Pti by Ti minus 1. So do you have any questions regarding this? Yeah, so then you can solve this questions. So this will be similar. There will be similar questions on hidden Markov model. So now let's go to the next one. In this question, what they are trying to say is consider this Markov chain. So this is a Markov chain like which shows the transitions inside it. So this is not anything related to the previous question because we do not have the post tag. So this is just the Markov chain for the list, the sequence of words, the W1, W2, W3. Now we have to now we have to see which of these following sequences will not be possible using this Markov chain. So what we have to essentially see that let's say for this sequence whether it is possible through this Markov chain or not. So how can you identify that as a sequence is possible through Markov chain? Can you tell me?
Just have to go through the transitions from the
Yeah. So So I think so anyone else can answer also. Okay. Yeah. So basically the answer is this: that we have to go through the transitions and see if it is possible or not. So
correct. So the last one we can't go back from W3 to the.
yeah,
So D will be.
I am coming to those things. So let us go one by
Yeah,
one.
it's fine to follow. I was just looking at the transitions. Yeah, please.
Yeah. Yeah. So let us start with the first one. So we are essentially starting from start. Then we have W1. Then we are having a self loop in W1, then W2 to W3. And the last one, so what is the problem with the last one? Yeah, now you can maybe answer.
So there's no transition from
Yeah.
W3.
So what this means is the probability. So whenever there is a transition, that essentially means that there is a greater than zero probability that we can go from that state to this state, like from start to W1. So from start to W1, we have probability that 0.5 probability we can go from start to W1. When there is no transition, it means that probability is basically zero. So this is possible that these like Markov chains like regular graphs. So they have connections to all the different nodes. One node is connected to all the different nodes, but they have some transitions which are uh, with zero probabilities, and that those transitions we cannot travel. So that's why this statement is not possible. So now can you tell me what is the answer? So you have to identify which of the among the following sequences cannot be generated by this Markov chain. So now it should be very easy. You can just look at the graph here and then answer. So anyone from either Srinath and Senthil, you can also comment if you have understood or not, and maybe tell the answer.
Actually, I have got
Yeah, but
next.
did you get this part, like this Markov chain part?
Yeah, whatever you explaining, it's okay.
Yeah, then so what is the like? You can also discuss the issues that you are facing.
Yes, yes.
Okay. So yes, the answer is here, and the answer is C and D. So you can very well verify that W1 we can travel to W1, then W2, then W3, but we don't have any way to travel to W uh, W3 to W1.
there is no path exist. So
Yeah, essentially that thing.
you are done.
Yeah. So what I'm telling is when there is no path, it means that the probability of going from that state to the other state is zero. So that is how it should be inferred. Okay, this was more or less a simple question. Do you have any doubts in this? I think. No. Okay, now coming to the third question. So so now this question is again based on the same transition sorry. Yeah, this question again based on same sequence key, fin and ENE, and they are using a maximum entropy Markov model with beam search and beam size equal to 2. So again there are different new terms. So maximum entropy Markov model. So what is this? So what is entropy?
Average expectation of surprise.
Yeah, yeah, exactly. So the quantification of uncertainty or surprise is entropy. And then, so in this, so now we can understand what is maximum entropy. So we are trying to model the uncertainty in a Markov model. And then beam search is a way of search algorithm, which we will see in a bit. So beam size equal to 2. And the features are given below. So there are different features, which so these features are only one or true when this condition is satisfied. So given a sequence, if so, for example, when will the F1 uh, when will the F1 criteria satisfied? So let's say we have a sentence which is T1 comma T2 T1 comma T1. Here if you see, let's say for this two, is the F1 criteria satisfied? So we can see Ti equal to T1. So Ti equal to T1 and Ti minus 1 is either T1 or T2. So it is T1. Again for this one T1 we can see it is T2, so it is also satisfied. So whenever this criteria is satisfied, this feature is 1. Okay. So these features are essentially constraint of the language model. So this constraint define. So this constraint in some way defines the transitions. You can say. So if Ty is equal to T1, then Ti minus 1 can be only T1 or T2. Similarly, if Ti equal to T2, Ti minus 1 can be null. So this somehow represents the transition, and we have to encode the entire transition tables from this, but that is not required. But the essence is the same, and we have these words with their uh, possible pause tags. So ki can be T1 or T2, fin can be T2 to T4, and ene can be T1 and T4. Now we have to assign a pause tag sequence to the sentence key, fin, and ene using this maximum entropy Markov model. So what it says essentially, so not going to into much details about what is exactly this. So P y comma x is given as 1 by z x by into e to the power summation of this value, and where zx is essentially a normalizing constant. And this is again, like, if you read the lecture, you will see that this is we get this the from solving a Lagrangian equation. That will not go into the details of them. So now we have to calculate. So So we have to calculate what will be the possible cost tax for this equation. Yeah, so let us try to find. Okay, so let us go to here. So what we have essentially, can you see my screen?
Yeah, it's black.
Yeah, okay, I will write
Yeah.
it. Yeah, so what we have essentially is uh, ki, then fin, and then yen, right? These are the words given to us, and we know that ki can be, so ki can be T1 and T2. Fin can be T2, T3, and T4. T1, T2 from the starting. So these are basically cost tags. So if we say I have a car, okay. So here we know what is car. It is a noun, right? So this noun represents T1 or T4. T4. So similarly, so these are because we have to, like, we are not working on real pronouns or something. So we have set this value. And we know any can be T1 and T4. And we have to find out what is the final post based on this maximum entropy models. So this is our question. Okay, now let us try to solve it. So let us try to see the and what we know. So this is the form. Yeah, so we know that E lambda y comma x equal to 1 by z lambda x e to the power exp lambda I fi comma x comma y. Now this fi is the features that we have got, and this zx is a normalizing constant. So this is given by y of exp given. This looks a bit complex, but it will get very easy as it x comma y. Okay. So these are the two things that we know, and this is what we will use for calculating this. Okay, so the first question is, so you have to find out first of all p of, so we have to find out p of lambda y is t1 and x is, so this is for the first term, so this term. So y is so sorry, x is ki, right? Any doubts up to this point? Any doubts?
Till here it's fine.
Yeah. So here, one more additional thing that we know is lambda equal to 1. So based on the question, if you see here, we have all the features have a equal weightage of 1.0. Now let us try to see. This will be essentially. So we will come to the zx part later. Z, let's say for now, and we will calculate. So now the basic thing to calculate is what is the this term. Okay.
So can we quickly do a recap of what lambda is? Because it looks intimidating.
Yeah. So let me go by this table. So this is what this part is what p lambda yx is. Now zx is essentially a normalizing constant. So what it essentially means is that we will calculate some p for this or some value of this function for this. This function will calculate for t1, let's say. Then we'll calculate it for t2, and then we'll just 1 by t1 plus t2. So this is what this is telling. So you have to, for each y that is there, so t1 and t2, you have to calculate the summation of this term. That is exp of summation of lambda I fi x comma y.
And lambda is equal to 1.
Yeah, lambda is essentially the weight. So how much weight are these features carrying? So here for simplicity they have given weight is equal to 1.0 for all the features. But let's say you want to highlight this feature. So this feature is more important for you. So you can have like 2 weight for this.
Okay.
You can reduce the
Wait
weight
for
for
each.
each for it. Wait for not each word. each weight for each feature. So the features can be thought of as transitions, like complex transitions. So that things is our features, and now you want to assign the weight to the feature so that you can like prioritize some features or reduce the impact of others. So that thing is the features. But here we do not need to focus on that. But if in main questions you are provided with some weights, so you have to take that into consideration. So here the work basically is how many of these are true. So based on that we can set the weight. So I will show. So let's say for the first case, that is uh, first case is this one, right? So what will be so then we have to essentially calculate. So here we have Ti equal to T1. Ti minus 1 is nothing, so null. Wi equal to Ki, and Wi minus 1 is null, and everything like Wi minus 1, Wi minus 2, everything is null. So now let us see which one of these are true. So out of these functions, yeah, so is this function true? Remember our Ti is equal to T1 and Wi is equal to Ki. That is the only information till now. So which one of these functions will be true?
Now, in the first case, Ti minus 1 is should be null, right? But here it's T1.
Ti
Maybe
minus 1 is
that's
null, yes.
so. Maybe the first
The first case
F1.
Ti minus 1 is equal to T1 or T2. So that can, so this cannot be satisfied, right? So you have to satisfy. So this is the AND relation. So you have to satisfy all the parameters. So we have Ti is equal to T1 and Wi is equal to Ki, and others, everything other than that is null. So which one will be satisfied?
Yeah, shall we go by feature by feature? First one, F1 seems to be not right.
F1
F3
is
seems to be
false. F1 cannot happen because Ti1 is equal to Ti is equal to T1, and there is an AND relation, and Ti minus 1 is equal to T1 or T2. So here the Ti minus 1 equal to null, right? So if we see this, this is null because we do not have any other words previous to this part. So that relation cannot hold. Then this one Ti is equal to T1, so this will also not hold. Then F3 Ti is equal to T3, this will also not hold. Then Wi is equal to any, Wi is equal to any, Wi is equal to P. None of them are true. So then this essentially becomes, yes, do you have any doubts? So this summation is 0 for this case because we do not have any features which are satisfying. So, so we will look into Z later, but yeah, so basically what we have is 1 by Z into e to the power 0. So now let us focus on the next part, that is uh, p lambda given p lambda as a parameter t2 comma ki t2 comma ki. So what will be the solution for this? Yeah, now Wi is equal to ki and Ti is equal to T2. Now let's again look at these features and tell me how many of them are true. Yeah, how many of these features are true? They just have to match it. So Wi is equal to one thing to remember is Wi is equal to Ki and Ti is equal to T2. So is the first one true? Hello? Yeah, just if you can unmute and say, it will be better. Yeah, the second one is the second one true?
I think we said all the features are. Now what
Yeah,
we're
for
trying to do is
okay, so all the features are false for this case, right? Where Wi equal to Ki and Ti is equal to um, Ti is equal to T1. This is the first condition.
okay.
This condition, this one. Now we are trying to see for this one. So where Wi is equal to Ki and Ti is equal to T2.
Okay.
Now, based on this equation or features, tell me which one of them are correct. Which of them are true? Sorry. So we have said that first one is wrong. Well, first one is false because Ty is equal to T1. What about second one?
Second one seems to be okay.
Yeah. Third and others are again like Ti is equal to T3, which is not true. Wi are not matching. So we can reject this. So only one is correct. So here,
Correct.
similarly, uh, this will become 1 by z into e to the power 1 because we only one feature correct and the weights are also 1. Now coming to the z part. So what was z? Z was the normalizing constant. So we said that for every Ti we have to calculate the summation. So z was for every y e to the power this value. So this value we have calculated for two of them. So here z will be 1 by e1 plus e0. Essentially simplify 1 plus e. And p lambda given t2 comma k ki chi equal to e by 1 plus e, and p lambda given t1 comma ki is k chi is 1 by 1 plus. So we have solved for the first one. Now, so did you get my point? So this part seems clear, right? Okay. So we will take a few extra minutes and like solve at least one part of it. So now let us move to yeah. Now let us move to the second part. So that is P of T2 given FIN. Okay. Now, so by Markov model, what we know? So every word is dependent on every Postak is dependent on this one word, so that will be sorry. So this will be this is so we have to calculate P of T1 comma T2 comma. So we are essentially doing the sequence. So we are doing the second sequence of the two words. So it will be ki fin given given ki fin. We have to say that postacks are T1 and T2. So what is the probability for that? So we can divide it into T1 given ki into P of T2 given fin based on the Markov model simplification. We already have the value for this. We have to calculate the value for this part, right? Did you get my point? Okay, so let us try to. So then you have to do the same thing. So whatever you did for the first case, you have to do the same thing. Now let us look at T2 comma fin. So this value you have to calculate. So how will I get it? Again, let us look at this. So here Ti is equal to T T2 and Wi is equal to fin. So again, which one are true? Are any of them true? Yeah. So none of them are true. So we can again say this part is 0. So 1 by so this part we can have already have. So this is 1 by z into e to the power 0. Similarly, if you check for pt t3 comma fin, this will be also same. If you look at the just, and we can again say it is 1 by z e to the power 0, and similarly for the rest. So pt4 would be the same. And how do you calculate z? So z will be e0 plus e0 plus e0, that is e to the power 0, that is 3. Essentially 1 by 3. So this way we calculate this part. So we have 1 by 3 into ti comma k1 will be 1 by 1 plus 1 by e. So this is the probability for this one. Did you get my point?
Yes.
Yeah. So now this way you have to continue. So this will be the final probability or transition table. So as you see, we have e by e to the 0 by 3 into 1 by 1 plus e. Similarly for other transitions, and then you have to do the same thing here also. And finally you will get different values, and then you have to try to find out which one has the highest probability. So whether which path. So if you first follow T1, then T3, then T1. So what is the probability for that? Then if you follow T1, then T3, then T4. What is the probability for that? So this way you will get four different probabilities. So you will select the maximum from here, and then you can find the probability of this posture, which is the maximum probability. So you can try to complete this at your home and then let me know if you have any problem.
So you will put this online as soon as possible because this will
Yeah, this will stay online. Yes.
because, it takes some time to digest. So that
Yeah, but you
notes will
understood till the
get
two steps,
associated.
right?
Yeah, that will help. It's very
Okay, so that is, I think, all for today's link. So this you can do similarly. There is another question in the same slide. So basically, you have to find out the probability of this sequence. So that we have already calculated. So that you have to see. Yeah. So the final answer will be T2, T4, T4 based on these different values. So you can calculate the values and then match them. Okay. So we are at the end of our session. So this will be the location of the YouTube videos and the slides. And these are again like shared in the discussion forums as well. So you can discussion forums as well as your NPTEL course catalog. So you can find both these things there.
So please update the Excel as soon as possible so that rather than moving
Yes, I will do that. Yes.
Excel sheet.
Okay. Thanks then.
Thank you.